Okay, hi everyone. So in this video, we'll take a look at Marlin. So in the case of my project, making the MMU2 compatible with any printer. So for the people that are new to my channel, what I'm trying to do is make multi-material upgrade. So adapt the multi-material upgrade from Prusa and make it compatible with any printer for as cheap as possible, while requiring minimal hardware modifications. So my plan was to use a 32-bit board, so the SKR Pro version 1.1, I believe, and to run Marlin on that, and because this board has 7-stepper motor controls, to be able to control the 3-stepper motors from the MMU2 directly. So in the original upgrade, so you have the firmware running on the MMU2 and you have the firmware running on the on Marlin or on the printer firmware, so version of Marlin if you're using an MK3, and the original firmware that was on there. And basically there's a serial interface between the main board and the MMU2. In our case, we don't need any interface because we are going to be running everything from the same board, which will be 32-bit, which means we will have absolutely no problem regarding like processing power or speed. So even if we are controlling like 7-stepper motors. So first, what you're going to want to do is go to marlinfw.org and simply click download, and then you can download the latest version or specific version that you want. You can also download it from there, from GitHub, and once you have downloaded, so download the zip, and there as well it's a zip as well. Once you have downloaded the zip, you simply extract it to the folder that you want to work with. Okay, so the upcoming part of the video is basically me showing where I'm at right now, or at least where I was a few days before this video. And yeah, anything I say is not necessarily true, and you should take everything I say with a grain of salt. I'm just showing you the process that I kind of went through to find the plan, so to say. So just to know which way I was going, and the different things I made, the tools that I'm going to be using, and also the different things I'm going to be working on first. And also, like, it's just to show you the process. So right now this video is not a tutorial, it's not an explanation. It's nothing that you should consider like, these are not facts, they are simply my interpretation of the code, which is not mine. It is Marlin firmware or the MMU2 firmware. So yeah, that's about it, and let's get back into it. Okay, so when you have downloaded and extracted the Marlin 2.0, or another version, because you can do this with another version as well. Once you have downloaded that file, well, go ahead and open it. I will show you a few things in there. Okay, so you can see that like with the version 2.0, things are way better organized in different like folders and subfolders. And if you were to use a regular 8-bit board, you would go into Marlin, marlin.ino, and then this was open like this Arduino file, and also the related like .h files, so the configuration files. You would edit the configuration files, and then you would simply hit upload, and it would transfer the code to your board. But now with the 2.0 versions, and particularly with 32-bit boards, which is what we are going to be using, you need to use Visual Studio Code and platform.io to build and export the firmware to the board. So since there are a lot of like folders and subfolders, and that I don't simply want to edit I don't simply want to configure it. I want to edit it. I want to have like make modifications to the program and add support for the upgrade. So I need to find a good code editor for that. So what I'm going to be making the video on is Visual Studio 2019, at least for the first one, because I'm too lazy to reopen everything in like Visual Studio Code. But what I would recommend you use is Visual Studio Code, because on there, so don't make anything like you have a Program Explorer and it works decently. So why I use Visual Studio 2019, because it has a really good solution explorer. So when I need to find something, I just type it in and it pops up and gives me everything in every folder where there is what I'm looking for actually. So I'll make the beginning of the video on this, but once I start to do real modifications, I will work on VS Code, because this is where you're going to upload it. Because you're using Platform.io, which is an extension for Visual Studio Code, and also Atom, but it's like right now I know that they are more focusing the development for Visual Visual Studio Code, and that's where we're going to be using that to develop, and that's what I'm recommending to use. So here, how things work is that the first thing I did was look around inside the different folders, see how everything was configured and created, and how it was structured. So that's like kind of like beginning to understand how things work and how things are like put together. And now I know that Marlin is compatible with the MMU2, the original MMU2. So it means that there is somewhere a program that makes a serial interface between Marlin and the MMU2. Or if you're using the official MK3, then it's still using Marlin, but it's using like edited Marlin from Prusa. And this is basically what is making the serial interface. Whoops. My mic almost fell down, but let's continue. So yeah, there's a file that is making the interface, and I needed to find it. And since everything is well organized, it was super easy to find it, because I have the Solution Explorer, which I mentioned before, MMU2, and here we have absolutely no results. And because I typed things wrongly. And once again, and now it should work. Yes, it does. So now we have a few things that pop up, and these are really interesting. So MU2.cpp and MU2.h. So what we see in MU2.h is that basically, like, it's definitely serial connection. So it defines like the size, so bit size, bit rate, and the public functions, so related to the multi-material upgrade. So these are really interesting. This is what we're going to be working on and try to reproduce on our board, so each one of them. And private, like to make everything work and to make the serial communication work. So we won't get too deep into that, because A, I haven't taken the time to really understand it properly, and B, this is not what matters, because we are not using a serial connection. We are having a direct link. So the main board is controlling directly the stepper motors that are driving that multi-material upgrade. So we don't need any kind of type of serial connection. We are working with a single board. So here are all the functions that are really interesting. So let's start with the init function. So the name is kind of like self-explanatory. Initiate the board, and here it is initiate the serial communication. So here I go Control F init, and it will find automatically where it is. And this function is quite simple. It's mainly to initiate the serial communication. So this line I would say is the most important. It starts the serial communication at the baud rate that is defined right here. So in our case, 115,200 for the baud rate. And then there's the reset function, and this is simply to user reset pin on the MMU2 board, so not on the main board but on the MMU2 board. This is not useful for us because we are not using a separate board. This is the actual same board, so we won't have any like serial communication problems. So both of these, so so both the init station and the reset functions are not necessary. Then get current tool. This will be useful, but we won't need to like ask through a serial process what tool we are going to be using, because we know what tool or what filament is loaded. So the tool is the filament in our case. So here there's the MMU2 loop. So it's basically depending on the state so that you define and that you want. It's going to send in each case a different information to the MMU2. This is basically like it's basically a loop. It starts at like if state is 0, that means that like it's not working. You break and you stop the program. In case -1, you start the serial communication and then you just get the version. And if it doesn't answer in this number of milliseconds, you just say that the MMU2 is not working. And then it's just like find the build number and use like the different things, check the find a sensor. So all these little functions are simply serial communications, and we won't need any of those. So it's simply like asking this code in the MMU serial communication for check the find a sensor, and then it answers the state of the find a sensor. Let's see if we can find it in there. No, it's not in there. It's in another program somewhere which defines every serial message from the MMU2. And this is not interesting for us. This is still the big loop. And what I'm going to take a look at here is the tool change, because as I said before, the tool is your filament. So tool change can stand for basically anything. It can be a laser engraver, or it can be a CNC, so a router, or well, a different tool. But in our case, Marlin considers, at least from what I've seen, a different tool as a different filament, for example. So here, it will be the tool change that interests us the most, because the first thing I want to be able to do is switch filament. Once we have done that, like half the work is done. So tool change, you have two functions. You have one which is a simple 8-bit variable which is called index, and then the other one which is like a special a chore, but I don't think it's used that often. I will see how I do that. And let's go Control F, tool change, and tool change. And we will go down to these functions. So here, this is the one with the 8-bit index variable. And as you can see here, you don't learn much. It simply sends different commands to serial to the MMU2, and then the MMU2 firmware handles all the different changes. So basically what I need to do is create another folder or another set of code with a .h and .cpp, and then find the different programs that use this tool change function, and use not the MMU2 tool change, but use my tool change. So I need to change. So I need to add a configuration file. I need to add this, and I need to add also the tool changing program itself. And I also need to modify all the different programs that interact with it, so that it knows that this is the new one that we have to use, and we don't use either none because in configuration it's disabled, or the MMU2. So we'll simply get inspired by that to keep at least as many like ZTM functions, and to know where we are like compared to the actual MMU2. So here, let's go to another few programs that we kind of need to take a look at, and after that I will show you the other source of information that we can find, which is extremely useful. So first, let's go into tool change. So this is the part of the program that simply defines how and what tool change you use. So the .h file is basically based on the configuration, on the Marlin configuration file. It will tell if what you want. So it will tell if you have like the MMU2 enabled, if you're using a magnetic parking extruder. I don't even know what that is. Well, I kind of imagine what it could be, but and in the CPP file, it's here that you have everything that is actually like defined and created. And the part that we are interested in is the MMU2. And here you can see that if Prusa MMU2 is considered enabled, so that would be part of the configuration file. It use for tool change, it uses MMU2.toolChange new tool. So if the multi-tool function is enabled and the Prusa MMU2 function is enabled and that you want to use a different tool, you're going to use the function of MMU2 tool change new tool. So the argument of MMU2 tool change will be new tool. And if we go back to MMU2 and go to tool change, we can see that new tool will be attributed to this 8-bit. So it will be an 8-bit value, which will be indexed and which that is sent to the actual multi-material upgrade. So this might be a bit confusing. I may even be wrong, but simply how it goes is this is kind of like branching out. So you have like the Marlin firmware that says, hey, I want to change tool, and this says, okay, do we have the MMU activated? Yes. Okay, then go to the MMU2 and say to it, change to the tool number 6, and then it activates the function in here, which is tool change, with the 8-bit that says like change to tool number 6, and then it sends it to the MMU2, and the MMU2 firmware makes like all the physical changes. So like rotates the extruder to remove the cable and put it back in, and all that sort of stuff. So I could easily create my own like set of commands to retract the filament, change the new one, check that so here we don't have find a sensor. If you've watched my previous video, we're using a simple switch. If the switch is closed, like that is loaded. But I still find it easier if I'm basing myself of another code. So if, what I'm going to do is, since absolutely everything from Prusa, or almost everything from Prusa, is open source, which I'm really grateful for because it is saving me a lot of work, I can go ahead and use the source code of the multi-material upgrade. I'm not sure, this one may be of the first multi-material upgrade. I'm just reopening the folder, and this may be the wrong one, but maybe it is the wrong, but you get the point. So this is the firmware on the MMU2. So this also has all the serial transmission files that we actually don't need, because once again we don't have any type of serial communication. And then you have all the different controls, like buttons, like what to do if this button is pressed, and wait, and all that kind of things. So this is the firmware running on the MMU2. So we're going to use that kind of do some reverse engineering shenanigans, and then make it work with Marlin directly without any serial interface. So this side is also really interesting because you have all like the different features that they have added, and I mean you could potentially modify it to add your own if you wanted to modify. Sorry, you could modify it to have anything you want. Change how the LED works and something like that. So this is really interesting. And yeah, we're going to use that and implement it. I just have to like simplify that. Just have to. So I basically have to simplify that. I will use something as similar to this as that because they have done all the research and I've given them a lot of credit for that. Like on the speed I need to use, on like the different timings I need to use, and I'll use this material and kind of copy paste it. Not copy paste it. It will require a lot of work, but I will place it inside Marlin. See if I at that point I'm thinking of two ways. Either I'm consider this like an MMU2, and I say that in the configuration file I say that I have an MMU2, and then I edit these two files to replace the serial communication. So I will simply go there, and instead of saying, hey, send that to that, I would say move extruder there and reverse it and do that kind of things. Or I could simply recreate another configuration profile and say activate multi-material upgrade on any printer, or not from Joseph Prusa, or whatever I'm going to call it. If you have any names, make sure to let me know. And create, so I will still use the same setup as I do inside features. I will add a folder with the different files I need to run. So the either way would be simply to go inside there and do really horrible things to that code in order to make it work. Or I could start from zero. If I want to include this inside the Marlin, so what I'm thinking about actually participating in the development of Marlin 2.0, and I think that I could add this to the actual program. So this is an open source project, so anyone can participate in it and add their own code if it's like well written and well implemented, and that everything is clean, and that you have like correct tabulation and correlate and that everything is clean, which would mean would require me a lot of work, but I think that this is what I will opt for. So let's say at first I will just try to make it work, so modify these and try to make it work, and once I'm starting to get actual results, I will rebuild everything to make something that's clean enough in order to be accepted inside the official Marlin build, so that someone at a later date that wants to make this exact project doesn't need to even touch a line of code, or well, they need to, but it won't be any different from installing Marlin because this will be already included, and you will just have to modify a configuration file. So that's my plan right now. Okay, so I guess we're done for this first video, basically explaining what I'm going to be doing on the firmware side of things. So quick update on the entire project. So I should receive the main board in a week. So if I don't receive it in a week, that means there has been delay somewhere, and since I don't have any tracking number for this board, I may have to order a new one. This would really suck, but it may have happened that the package got lost in shipping since it's coming from China, and the situation right now is not the most stable, if I could say that. And so I really hope that it arrives rapidly and in one piece. And once I've received it, I will be able to start doing some prototypes and programming, because a big part of programming is being able to test your result. So you change a few things, so you modify your code, and then you test it. But if I'm unable to do the testing part, I may spend like 100 hours on something that just doesn't work from the first line. So I need to have the actual physical product in order to be able to really go forward with the firmware. On the physical side of things, so there are a few things that I made, have done, and need to do, but I will take a camera out so that I can show you basically everything I did. I will be back in a sec. Okay, so the sound is probably bad because I'm in a small room with literally no sound cancellation, but okay. So there are a few things coming up. So first there is a self-rewinding spool holder. So this design is, I will speak more about it later, but it's basically a copy of someone else's. I'll put his name in the description because I don't remember, and I just made it like easier to print because it was made for the MMU2, so it used like the other MMU2 parts. So I made it in a few pieces that just like clip in together, so it's they press fit together. So you can simply print them like that. So okay, let me remove that here, and as you can see, like it's well fit. You can print it like that. It prints super easily, and then you just assemble it. I will need to do one last change to this, and it is simply for balance purposes, because right now when I put the fully loaded spool at the end, it rolls over. So I'll make a video about that. So the basic principle is that there's a slight slope and then it rolls down when it needs to rewind, and when it goes to the top it is flat, so it rolls freely. Another thing, I need to do a few modifications to other parts so that I can assemble the thing fully. So I've already done all the main modifications for the let's say parts individually, but I still need to do a few modifications. So first I need to make the holes, so on the idler body, so this orange part right here, these holes bigger, because they're supposed to be spring loaded, and I want to use like 3D printer bed springs, because these are the one that I had on hand, and as you can see they don't fit, so I will need to make this hole bigger. This won't be difficult at all, and I will take the time to also make this end stop bigger, because I said that I was going to do it, and since I'm reprinting it, I'm just going to make it bigger. So I've already done that, but this piece right here has had print defects because it came off. And also relating my printers, I have the ANET E10, which is absolute garbage. And I've finally received my new printer, which is the Ender 3, which is a huge improvement compared to what I had. This one is extremely reliable, and it gave me the ability to use PETG, because I was unable to make PETG work, and I was able to print a carriage. So it's let's see, there's the name here. You probably can't read it. If you have an NA10 by any chance, just comment it down below and I will link you this specific part, but you can find it on thingiverse quite easily. I printed it in PETG because it is quite close to the hot end, and this way it cannot melt. And so let's compare it to the previous let's say carriage. So the way this thing worked is that you had your two bolts with your little wheels on here, and I have no clue why they did not put the third wheel in the middle. They put it on the side. So when it was on there, it was at the beginning it was alright, but once everything was kind of like getting used more and more, it was able to lift off slightly. So when it was going this way, it would lift off slightly, and I wasn't able to get any good adhesion, and it will also warp during the print. So what I printed is basically replacement, and the third wheel is right in the middle, so now it's well balanced, and I can see it cannot move, and it runs smoothly, and it's just a huge improvement. So basically I got a second printer. I managed to print a piece for my first printer, and this way my first printer is now way more reliable, and I am able to produce way more parts than before. Like, it's not even twice as much, because now this one is way more reliable. I would say it's like 2.5 times more parts, because a lot of the time on this printer, prints would fail and I would have to restart them, and this way I'm also wasting less plastic. Speaking of plastic, I'm using a a lot of plastic, so I don't know if you can see here, it's like all the parts that actually failed, and I have like 6 different prototypes for each part, but it's not really a problem, it's part of the development cost. So on the physical side of things, update on the self-rewriting spool holder in a matter of days. In the entire assembly, working assembly should be a few weeks away, so let's say I will give myself 2 weeks to make all the different parts work. And yeah, once I will have received the hardware, I will begin to make modifications to the firmware, and this is starting to get together quite nicely. I also have to clean up everything, but that would be what I will do after this video. Okay, so thanks for watching, and I will see you later. Bye. Oh, and one last thing for the people that have watched the video until the end. I was thinking about adding music, so background music into my videos. Do you think that this would be beneficial or on the contrary, do you think that this would have a negative impact on my videos? So definitely not too loud, because I really dislike when like YouTubers have a background music that is way higher than their voice. So make sure for it to be like not too loud. But I want to know what you think about it. So just tell me down in the comment if you would like to see that added, or if on the opposite you think it wouldn't add much, or it could even be negative.